Hi everyone, this is denture TAKA-Channel. Well, I upload the video after a long time, so this time I'll talk about dentures. Well, look at this. Have you ever designed a full denture with an intraoral scanner? It's not resin based, it's a metal based full denture. So today, I'll show you how to make it only with an intraoral scanner without taking the impression. So you might think it's really difficult, but it's not. But don't worry, you can get lots of notice by watching this video. So this is a fully digital design denture I designed. I don't know about other countries, but in Japan, the metal base are often used for full dentures in edentulous jaw cases, right? So I tried to make this denture using the 3D printer and scanned by Torios and designed by 3Shape Dental System. Okay, let's take a look now. Well, let's display each data after the design. That is residual ridge, the metal base, the resin base, artificial tooth with 3D view. The data itself is independent, but since the coordinate axes are the same, you can see them in layers. Since each material is different, right? The manufacturing process after design is also different. So artificial teeth are really made artificial teeth. In order to integrate these, it's necessary to prepare a model with the 3D printer. It's very different from the manufacturing process of crown, the braces, and implant processes. There are still some issues that need to be resolved to make a denture in fully digital process. Most things can be done digitally. Expect for some analog processes. This time, I'll tell you about the process of the digital denture that I tried. It's a denture designed with a dental system, including the 3D printer model. The metal base is cast with a cast wax using the 3D printer. The resin base is also molded with a 3D printer. For artificial teeth, the Shof's artificial teeth were scanned one by one with a desktop scanner and registered as an original library. So we are using ready-made artificial teeth. A model was needed to combine the metal base and the resin base into one. So I made a model with a 3D printer, but I didn't make opposing teeth. Also, no need for articulator because the pairing relationship is complete on the dental system. That's the reason. Okay, let's watch the video step by step. The first, let's take a look at the data folder taken by Torios. So information on the upper jaw and the lower jaw and the left and the right bite is available in scans. This is a bite information. This is the right, see? And this is the left. All right. The 3Shape original file format is DCM. The lower is the data of the opposing tooth. So this is the security monosig zirconia superstructure completed earlier. And the upper is the data of the maxillary, which is the data of the existing denture with the bite pressure impression and the denture taken all around removed from the oral cavity. So the bite pressure impression is the compressive state of the denture mucosa when using the denture is pressurized in order to improve the fit of the denture's occlusal mucosa. At impression with the patient on occlusal pressure, right? There is 4 data. The maxillary denture data must be converted to SCL. So processed with a MeshMixer. Since the original data of the Torios is DCM, in order to convert this to SCL, The maxillary data is once returned to the tutorial software to STL. So first, make an order form and import the maxillary DCM and export it immediately. Then the scan and the 3O exit are displayed. So please select the scan and see, and the file of type is DCM. Change this to STL, right? So then enter the file name. Let's take a look at the data exported as STL on the desktop. See? So now let's import this into the MeshMixer. Open the MeshMixer and click import in the upper left. Then load the STL from earlier. It was displayed, right? As I said earlier, this is the data impresses the occlusal pressure in the existing denture. So in other words, I want only the mucosal data in which the mucosal membrane is evenly pressed in the oral cavity. So I'll trim the unnecessary parts because I want to make it work data, right? So there's the brush mode in select on the left toolbar. The type is unwrap brush, so you can also change the brush size. If you check the symmetry, the brush will select the range symmetrically, as you can see. When setting the rough range, you can work very quickly by setting this mode. The orange color is where I want to remove it. So be careful near the mucobuccal fold of the denture. To check if there are any unpainted areas and click discard in the edit item. Then all the orange part is disappeared, right? I want to use the data of the inner pink surface as work data. So therefore, this is not the end of processing. To do this, we must change the perception of the front and back of this data. So fill the gray surface, that's the surface with the brush mode. If this is also symmetric, it will be easy. After filling everything, click invert normal in edit. Then the gray side and the pink side were switched, right? The front and the back side are now flipped. Decide the file name with export on the left toolbar and export it again with STL. Alright, this completes the data processing of the maxillary working model. Now, let's design a metal base with a denture system. To design metal base, you need to create the order form with a removable partial denture module. Since it will be 3D printed with castable wax, the material should be wax. In scan settings, set the target to optical impression. The opposing teeth data is not needed here. Why not denture arrangement and the metal base in one order form? This is because metal base can only be designed with removable partial denture module, and the removable partial denture module doesn't allow full artificial teeth alignment. That's the reason. Okay, when you open an order, the first thing to do is preparation. Decide on the outline. I'll use the data processed by the MeshMixer earlier as work data. Since this data is STL, it will not be displayed in color. Doesn't matter. Put the data of the denture before processing in the additional scan. On the engraved maxillary screen, use the wax knife tool to form a postdam. See? The denture can be displayed semi-transparency to check the base outline and arrangement. So next, decide the insertion direction and use the add tool of the wax knife to relieve the necessary parts. Once the preparation complete, it's time to design. Draw an outline goes into a resin base denture with retention grit. Decide the outline while arranging the existing denture. See? Set the hole shaped retention to be located at 0.5 above the mucosa. This is because there need to be a space for a region between the mucous membrane and the retention grit. And next, decide the outline of the metal base on the part side in the large connector item. Set the substructure thickness to 0.9 and the wax thickness to 0.3. I think this was default value. So display the metal base in the preview to check it. Alright. See? In the finish line item, form a line so the boundary between the metal base and the resin base on the part side is transitional. The metal base design is almost complete. You can always display existing denture to check your design. So how is it? It's important to have an accurate outline, but the rest of the design is very easy. You can change the pattern of the stipple wax on the final confirm screen. Alright. For example, the medium type 1 looks like this. See? The pattern on the surface of the metal base changes. So let's try some. This is a fine type 1. There's also something like melon texture, right? I tried various things. But in the end, I decided to use a fine type 1, which I choose first. Well, anyway, this completes the metal base design, right? Export the designed metal base to STL and print it out with a 3D printer. So print out with a castable resin, then investment, the cast, and the polish as usual. If you can do a metal printing, that's better than this way, I know. However, this method also gives good result. Okay, next is the design of the denture model. So select the one any tools from the order form. Otherwise, the model module cannot be selected. That's the reason. So select split on the left side of the model module and abutment tools on the right side. The data of the maxillary was displayed. Select the widest possible range on the generate abutment tool screen and let it be recognized as an abutment tools. This is a mucosal data recognized as an abutment tools. After that, design the frame surrounding it and complete the design of the virtual model. Okay, let's take a look with the 3D viewer. The outer frame and the mucous membrane are designed in two pieces. See? The reason for designing as a split model is the mucous membrane part recognized as abutment tooth is printed out with soft resin. and the outer frame is printed out with the hard resin for model. This is a model printed out with 3D printer. The outer frame is hard resin and the inside is clear soft resin. The reason why I choose soft resin is I wanted to create a situation similar to the actual oral cavity. That's why. You can see the soft resin is as soft as rubber. See? Add resin on this model to integrate the finished metal base and the resin base. In other words, the metal base and the resin base are fixed on this model, and then pour it into those gaps and integrate it with resin. As I said earlier, metal base can only be designed with the removable partial denture module, and the removable partial denture module doesn't allow full arched artificial tooth alignment. So therefore, the order form for artificial tooth arrangement selects the anatomy module and the gingival module. So now, let's make an order form for artificial tooth arrangement and the resin-based design. The arrange 14 teeth from the 17 to 27 for the anatomical module. Select the artificial tooth type. For the gingival module, select the glued-in teeth. Add study model when the order form is completed. Click OK to enter the design screen. So first is preparation. Use additional scan on the toolbar on the right to load the metal base I just designed. If you open the CAD file from the solution files, you can find the data only for metal base. All of this is done in the same database, so the coordinate axis is the same. See? Therefore, the metal base is on the residual ridge data without any alignment. Use a wax knife in the engraved maxillary item to relieve the metal base mesh. That is, the part will be combined with the resin base until it's completely covered. Please relieve firmly so the molded resin base and the metal base do not interfere with each other, and the poured resin can be packed. See? So the cover everything with add tools and then smooth the surface with the smoothing tools. Alright. The mesh part is now firmly covered. The next is a model analysis screen. If you display the byte data and give 3 points, the flat plane will appear. See? Display the denture and decide the occlusal plane. This denture is already made in the proper plane and the middle position, so move the flat plane up, down, the left and the right accordingly. So next, point on the upper jaw on the characteristic point screen. So first, decide 2 places around the little more, and the left and the right canines and inside the papilla. Next on the maxillary boundary screen, decide the outline of the base will be the resin base. At this time, I think it's good to draw a line with the high-speed line editing. On the parietal side, draw a line at the boundary with the metal base. With the high-speed line editing, you can draw a line smoothly. Right? So next, decide the insertion direction on the broker screen. If there are more red parts stronger than undercut, so set the direction that there's as few red parts as possible. So now it's time to arrange the artificial teeth. I've already registered the original artificial teeth tooth library. So this time I will use Shofu Balancial artificial teeth for both anterior teeth and the molars. So select the type of the size and the artificial tooth at the bottom of the screen. And the artificial tooth is displayed. Since the artificial tooth seems to be a little small in the front tooth part, I changed it to a larger size. The first alignment all over. Use the transformation tool to move the entire artificial tooth based on the artificial tooth. And then arrange the anterior teeth one by one. So display the denture semi-transparency and refer to its arrangement. In case of the crown, the bridge, and the implant, you can change the size and the length of the order for deform the shape of the tooth selected from tooth library. But since this is an artificial tooth, it cannot be changed in shape. Therefore, you have to choose an artificial tooth of the appropriate size from the library. I'm not used to this arrangement yet. At this time, the front teeth on the right side were arranged first, and the right side of the molars is arranged as it is. Arrange artificial teeth while always paying attention to the positional relationship between the arrangement of the temporary dentures displayed in the blue and the posing teeth. The display the flat plane and arrange the other side as well. Arrange while checking whether the midline position is correct and the planes are evenly arranged on the left and the right. If necessary, adjust the right side as well. Don't forget to check the entire tooth axis, the occlusal contact, the overjet and the overbite. And the artificial teeth should not overlap each other. So this completes the artificial tooth arrangement. So next, decide the outline of the maxillary resin base. After deciding the outline, let's display the resin base in the preview. At this time, the thickness of the base is set to 1.4 and set the gap between the artificial tooth and the resin base, that is the adhesive gap, to 0.15. See? I think this number can be glued to the resin base in the correct position without adjusting any artificial teeth. Alright, after that, the gingiva is formed with a wax knife and the surface is prepared by smoothing to complete the design. It's the final confirmation of the design by designing the matched 3D face. The entire face artificial tooth arrangement are in harmony. There is no problem with arrange from the left and the right sides with the 3D face like this. My design won't fail. This completes all the designs. Everything except artificial tooth is molded with a 3D printer, but the resin tanks use all different. What do you think of the process so far? Let's see how the real denture is finished. Alright. When I put the ready-made artificial teeth on the 3D printed denture base, it fits perfectly. No adjustment is required. Just glue all the ready-made artificial teeth to the denture base. So I first glue the artificial teeth and then fix the metal base and the denture base on the 3D printer model. Once everything is fixed, all you have to do is polish it. This is a maxillary full arch denture that has been completed after all the steps. See? Designing all resin-based denture to a denture jaw case with a dental system is not difficult. I'm not sure about other countries, but in Japan, dentures use a metal base for both the upper and the lower jaws, the main. As see, as shown in this photo. That's why I had no impression. That is, I was thinking of the way to design a metal base and a resin base with an intraoral scanner and integrate them accurately. And I was able to complete it like this. I also hoped this denture would fit and function well in the oral cavity. Alright, this is a completed full denture is attached to the oral cavity. It's fit to the residual ridge and there is no division in the arrangement of the artificial teeth, and there is almost no need for occlusal adjustment. The pairing is the security mosaic zirconia superstructure completed earlier. I'll say it again. In this video, make an occlusal pressure impression using the existing denture for maxillary denture cases. The data obtained by scanning the entire denture with the Torios is stored on the MeshMixer. Make a metal plate with the processed data on the dental system, the designed artificial tooth arrangement, and the base. I use a 3D printer to make a model for fixing all the independent, the metal plate, the resin base, and the artificial teeth. I don't make opposing teeth. The denture was made in full digital process, right? But I think I was able to prove the good result. Please try it yourself. I'm always thinking about what I can do with a digital device and the software. So digital dentistry will continue to improve, and it will go faster than we think. And I believe it will be more accurate and easier to use, more attractive. Let's enjoy the digital world with the refusing to change. I'll continue to provide useful method for you. Please subscribe to Dental TAKA-Channel, and if it helps you, please also like. Thank you so much.